So we are gonna really jump right in. We'll start exactly from where we left off. And if you remember, we tried to define like the modules I would be requiring, and so we are about starting off the definition of our services, and that's exactly what we'll do right now. So let's jump right in again, guys. Okay, so now we define our services. So there are a couple of ways we can actually go about this, but let's just say we decide to, I don't know, group them by methods, for example. There are a lot of ways you could give. I'm just giving you a hint of like, just to give you an idea of how you could structure it. So we'll say gets, there's going to be a gets module, and within gets you could have commando users, or you could of course manage groups, and we more or less can do the same for, say, for a post, for example, and delete. So what I'm thinking is to have the option to say, for example, when we want to do gets, so the gets could be user groups in this case, and post as well, and then we can more or less kind of like have them on such groups. Again, I decided to group this based on methods. You can actually turn it around and group by users, and then the users or the services themselves would then have the methods. Either way, I just decided to go with this. I don't know. Either way it works actually. Yep. So the next thing we would do actually is to then define what should happen for each of these modules. So we can actually start with users, for example, and we say in here, so we want you to be able to say get users and then user, something like that, and then you give us an ID, and then we'll give you the user. I don't know. So we define. I don't want to define another module. I want to define a user function that takes a user ID, which is a string, and returns a user model, right? And so here I would have to, so we can do something like user model, we'll say new, and we pass the ID. What is the problem? Mismatch or above? This is fine. I can just give it a name here and say user module, right? And then here I can say return dot say get, and why are you no such associated item user module. We've not actually defined the methods that we said we would want to define for each of these for any of the objects that inherits our yep. So if we go back here to modules, for example, and we go to user, so we've implemented the service factory traits, but we are yet to implement the API methods. And so anyways, we can come down here and import the API methods for user model. So new, like we said, it says it has to take an ID of a string, and then return common and return a user model. I would come back to you first. user model, and let's have to, and of course we can see reference to switch self. Tony, seriously, dude. And you can say ID that we got. And so now we need to look at the user model. So here I actually don't have this beforehand, and I can actually make this optional. And we do same for this guy. And so that in here we can say name on, and we say email. I mean, of course, there is the builder model where you can actually define, that can basically help you define. You just have to use the shorthand since the key and value are the same. So we need another function called get, and thank you. So get should take a reference to self, not a reference to ref, Tony. And return so this of course should be a pointer to an object at the heap. And so here of course we return our box.new, which again returns self, and ID. Let's clone at the ID, guys. Let's stay with me here. Let's clone the ID. String .new. Why do I keep saying that? .from. And I would say some test user, and yeah, of course it's an optional argument, so it should be, I'll copy that so I don't want to type that in English. Some, and of course we have email, which should also be some. And I'll say tests .user.email.com, I don't know. And you also need to implement gets. We'll use gets to return multiple things. Help me. So it takes reference to self, and it returns common. Returns a vector of self, of user models. And so we also give it pointer to an object on the heap. Self. We return a vector. And the vector would of course look something like this guy, so just put this guy in here. So this would be this would be fetching data, say from some database more or less, but now we actually just returning something static. Now let's add one more. And so we say test user, and we say, I could say some other test user, say, and then we also say yes, some other test user, and say another test user, and the email will be of course another test user. Thank you. And it's still complaining because we've not implemented all the methods. So we have gets, and now we have post. So it takes a payload. Each of course has to import service factory and return either nothing or an API. So let's just print our, say, payload is this, right? And we simply return okay. It's not really doing much. And what else? So complaining, input doesn't implement display. Okay, let's take care of this guy first, and we can come back to you. And let's just say okay for now, so we can focus on the main things. Thank you. So now the implementation for API method should be complete. No, I think here we only need to import the thread. The thread should be in hand. User model. API methods. Yes, here we only needed to import the and expected. So yeah, of course we have to unbox. This should be fine. But we have to need to fix. But let me fix this first. Post models. Sync fn. Just done it already in get, so we don't need to say get users anymore. We simply say maybe users. So it doesn't actually take anything, but it should return a vector of user model. Thank you. Close that up. Should return a vector of user models. And so here again we make some query or do some operations. So but here we are not going to do none of that, so we only just gonna maybe return a user. Let's do something weird. So let's create a user. This is just for tutorial purposes. UUID, thank you. And we say new v4, and we convert to string because we need a string in the end. And now we say user module. This is just for tutorial purpose. User module, let new, and we pass that user ID, and we can just return user module get. And we have to close it up, and I think we have to unbox one more time. And I think this is looking good, pretty good. So what we can now do actually is to go back to our handler and try to use the functions we've defined. So we go back to main, and under get here it starts with users. Cut this out. And we say what's gonna happen. So what's gonna happen is, let's assume we would get an ID from the URL, right? So save this, we call it user ID as a query param more or less. And if nothing, we can't find anything, we leave it as empty, and we call it this. We're expecting something called ID. And so now what we can do is, let's say, of course, we always have to return a message and a status code from each of the blocks. So we define a variable without allocating anything yet, And now we say if ID, we're trying to see if we actually got something. If it is an empty string, so if no user ID was specified, we say the results would be equal to, sorry, let's say get. And now we need to, of course, import our modules, or sorry, our services. So we put them this way. So use create handler, and let's go into so we need our model, we need our service. Inside our service we need our delete, of course. We need our post, we need our get. That's fine. Of course, we close it up. And so in here, what we can actually do right away is to say if no user ID is so if an ID is provided. So now we say our results would be our get. We say users, and we say user, and we pass the ID. And as you can, this would give us of course it's an async function, so we need to await it, and the results we convert it to string. So we use a one-liner to return this, and we say else. So if no ID was provided, our results would become, of course, we first fetch all users, and we say let users would be equal to say get. We are, as you can see, we are using users because we know the service we are inside. You know, we don't need to say groups. No, we already are aware of the service we are talking about. And we say users, of course, and we await. So it's also going to return a vector of modules, and then as a response, now we can also use set a JSON. We use set a JSON to string, and we pass a reference to users, and sorry, and then we expect. We don't want to wrap. We want to expect. We can say failed to fetch users from the database. And so what is the problem? Oh, of course, I named it user ID. So let's be consistent here. Okay, so we have and now we just need to return our results, and we say is a get, so we say 200, and that's it. And now we are able to consume our APIs to fetch either a single user or a group of users. And we can test this out, test it again, service users, and see it fetches everything. And now this succeeds. And so thank you. So let's do something for post. So posts, under post users, we can do async fn, let's say user, and here accept a user module, and we return, of course, when you post successfully, it's either we get nothing or we return our custom API error. And yep. And so here, what we do, we simply say user module, say posts. Do we have a post method implemented? And we say box user. Then this should do it, right? This should do it because we already have our post method defined. As you can see, it's like static method. So we can use it without instantiating the user model. That's just the point. So we basically just do the same like we did before. So we go to, let's just assume of taking care of gets. So we go to post for user, and we say let body. We are expecting, of course, a payload from the user, and we are getting this from the body method of event. So we get what is interesting for us, which is the body test. So if we have a body test, which gives us a test here, which is a string, if we actually have it, then we want that test, right? And if we don't find what we are looking for, here we can already return okay. Return a response, response builder, status, give it a status of 400. Body, what should be in the body? We can say body text, and in here we can simply say bad request string, and let's format that and see where we are. We need to unwrap this. Unwrap it like this. So this is okay. This is okay. So we put this in a block. And this closes this, and so now we have our, so now let's define, so let's just assume that you're sending a payload that would represent this user. We get it out of the event body, and then we'll put it in a struct. So let's call this pay, and say no. Say we need to, of course, get this object from the payload and map it to our struct. So we need to serialize this. Now we have our payload, and now of course this gives us a result, because it gives us an enum, of course, a result object, and we need to match. So we can now call this, p user whatever, and let's just call match p. close this off, of course. Oh, of course, we need to define what this what types we are expecting from the deserialization, of course. So I think I can actually just click on this and it will, yes. So this would just be, just get this out of the way. I'm more interested here. Say this will be my model, user model. Okay. Yes, thank you. Yes, of course, we are still not returning what we need to. And I can say let's response, which will be of type string to hold our response message. And we have a status code. Let's make it of type u16. I'm gonna say to 1. Because we want a created status code if everything goes well, and that's why we're making it mutable. So if it doesn't, we simply just return. If it doesn't, then we mutate it. If it does, then we leave it as is. That's what we want to do. And now, of course, we return our tuple, which is expecting our results and our status code. We are not actually doing anything yet. So now we need to actually do our host. We see users, and we say user. We want to post a user, and this is where we'll pass the p user. And of course it's async. We await it, and then we match the arms. If everything goes well, we don't really need anything because we know we are not returning anything. So if everything goes well, you can create a response string that should be something like this. I'll just dump in some JSON. It says message. Now, and we say, come on, I also need to skip this, guys. Send message. Message, and we'll say guys that we need to escape. So inside here we now say successfully added user to the database. Of course we make this a string. Did I miss something? So this is escaped, this is escaped. This is not necessary here. This is escaped. Go. This is also escaped. And then no, actually this does not need to be escaped. Yes, this does not. This is fine. So we have our string, and that's if it goes well. Status code stays the same. But if there is an error, of course we get our custom API error. We want to propagate this back to the user. So we can actually say our res becomes e.message. status code becomes, maybe we say, I don't know, internal server error 500. And yup, so we get the object from the user, we serialize it to our user model. If it fails, we throw this error, and then we post it. Actually, if it's successful, we have this to give to the user, and if it fails, we return a server error and then the message that's been propagated back to us. And we can actually test this out to be sure. I just restarted this server one more time, and we can, I'll just copy this guy and create a new request and make this, of course, a post. And so for this, I think I need ID. Where is my model again? So name and email. So come back here, ID, whatever, it's your name, thank you. Seriously, guy, allow me, Tony, and say email. Thank you. And I think I can also make this a content application JSON. And then I send the requests. Should I need to be in the space here? I think. Always make a mess. So it was successful. As you can see, this is working as it should. And maybe the last thing we'll just do like a delete, and that should be, we'll wrap it up. And okay, so I can close this up one more time. Go to services, and we go to this. We go to delete, and again we go to users. So async users, of course, user will give us the user ID, which is a string. PIA, thank you so much. Async, of course, don't need, that should be a function. And what this does, basically, we simply say something like, just say it, user with ID has been deleted. Now done, okay, that should be fine. Is not imported, of course, so we can use create. Fine. So we come back to our main, and then yes, we have gets implemented, we have posts, and now we can do some delete. And I think for this also it's going to be pretty straightforward. So what we want to do also is like what we did here. So we assume that's when you want to delete something, you should be able to tell us the ID of what you want to delete. So we can also call this user ID, and we get something that says ID. And like before, we say let's results, which is going to be of the string, right? And of course, we also have a mutable status code. Let's set it equal to 200. And we see, now we match, of course, we match again, delete users. You can actually make it in such a way to look like you have something like delete user and then just put the ID. That's cool. That would also be cool. But yeah, user ID, wait. We are matching it, so if it is okay, if it is okay, we have something similar. We say results would be equal to this. That's to string, no, and why are you down there? What is wrong with my error? We also have an error, which is getting propagated as well. So we say result would be either message, and we say status code. Let's just say server error for now. And so in here, let's also do something similar. So we supply the user a JSON string. So we skip these guys, and here we can say message. Also the new guys, we skip them both, and now inside them we can say users being successfully deleted, whatever. And down here, of course, we have to return something. So let's test this out. So let's test it out, of course. So you make another request, and we make this delete, and we are providing an ID, services users, and I don't need a body, and it's done. Send request, and user successfully deleted. So this is looking cool. We can now do some cleanup. This is not needed. So do we have any unused imports? Nope. So I send it to cleaned out. So this looks good. This looks good. And now this looks good. So now we have successfully written or structured the lambda in a way we can actually really handle a real number of loads. We also define the custom error that would allow us to structure our errors and give them like a defined signature so that we can actually have full control as to what the error should look like. And we are also able to actually bring this all together, have them grouped under services, and handle different HTTP methods in the process, and also of course structure our code like really well. And so the next thing, which also is another fun part in my opinion, is actually the deployment part. So this, like I said initially, we will do with CDK, and this is also really interesting. So let's move on to that. Let's get started with the interesting part of deploying our code to AWS cloud. I created a folder called ISC, and in here I need to initialize a CDK project. So I could say CDK init app and language type, no, language Golang. Let's do this in Golang. Should be fun. Should really be fun. It's not a lot actually, just okay, I can't say Golang, I can just say Go. That's also fine. Okay, so let's see what we got. We got a git ignore, we got a CDK JSON. Our interesting file is of course isc.go. And I don't know if you're familiar with working with CDK, but when it comes to AWS, of course, when you do IAC, you get the option. There are actually like a lot of tons of options out there to actually do IAC. So there are a lot of third-party tools, but CDK, I love it because it's also like really from AWS. So with AWS, you have, of course, you have SAM, you have CDK, you also have CloudFormation. But for me, the most interesting one has always been CDK. Like when I got introduced to it, used it for a while, I actually really loved it. And since I've been experimenting with like Golang and on Rust, I've always loved to just work in these languages. And of course, CDK is quite interesting for me because it gives you that opportunity to work in the language you are really, really comfortable with. And for me, Go happens to be one of those languages. And of course, you can use other tools like Terraform, serverless, Pulumi, whatever. Yeah, but CDK cuts it for me when it comes to AWS because I also like to use tools that are really native to the cloud I'm working with. CDK is really good for me. And CDK, just like a overview, I'm also going to put the link to all of this on this video. But CDK, like just to tell a little bit, basically allows you, of course, to work with the language you're comfortable with. It works with the concept of stacks, where you can actually group your deployments into stacks. You can actually publish these stacks and people can actually download them and reuse them. If you have an application, for example, that say involves, let's say, a couple lambda functions on DynamoDB or RDS or whatever, like EC2, whatever, you can actually have this either as part of a stack that's your teammates, for example, can actually reuse in the future. You know, if for example let's say you publish a lot of lambdas, you're working with load lambdas, for example, you could actually have a stack that just does the deployment of a lambda, so that in the future when you or your teammates want to deploy lambdas, they could just use a stack, and just like the way they would use a regular function, they pass some arguments and then their lambda gets deployed, basically. You know, and every application which is part of a stack are all managed together, so that when you tear down the stack, it also tears down every resource it has created. So the first thing we need to do here is to download our packages. So we'll go more tidy to download everything we need. Just initializing the project, this is what we get. We get a CDK JSON, we get a test file where we can of course write tests to test our stack. We can test like what is being created, what is, you know, like if your stack is supposed to create 10 lambdas, you can also test if it actually does create that. So basically it synthesizes a CDK CloudFormation template, and then you can actually then just tear this template apart and try to see if it has what it should have, because of course CDK works with the concept of basically synthesizing the CloudFormation templates and then close this to AWS, and then AWS provisions these services using the signature of this template. So while that is downloading, we can take a look here. So we have our stack. Of course, if you look here, I named the folder IAC, so this is why everything is named IAC. And inside the stack, we initialize a new stack with some props. Inside these props, there you have the option basically also to even extend this, and then if you wanted to also like make it this, or if you want to give the user of your stack the option to also, for example, specify which regions and to which accounts this gets deployed, you can also add this as part of the props to this new IAC stack function over here. And this is the main function. The other important part I will also want you to take note of is this env part. So when it comes to env, as it's also clearly written here, you have the option to either say nil, in which case you give the consumer of the stack the option to specify the region and account themselves. So the point is that it is actually region and account agnostic. It can be deployed anywhere depending on where the consumer of the stacks want to deploy it. Yeah, of course, like, you know, when you specify the environment, and then of course this would always be deployed to this environment. But let's give it a while for this to install the packages we need, and then we can proceed. And so basically what we need to do now is just to create our lambda function and maybe put it behind an API gateway. I don't know, I don't care. And then just to test out our lambda function, that's really important for us. And so we have some imports already here. Maybe what we can already do is import our lambda function. I would think should be as github.com/AWS CDK go CDK v2 here this is actually AWS lambda, and yes, now we can define a function and say our function is of course equal to lambda. That's a new function, just to be sure that's correct. So new function takes scope. Most stacks in CDK always have the signature, scope, ID, and then props. And the scope is always the stack we created. ID, we'll use JSI, and the string, give it a name, call it, I don't know, my function, of course, Tony has to be a string. And the next thing it takes, of course, props. Like I said, most stacks, CDK, written like that. Function props. And so here we defined a couple of things. We defined the runtime. We will use actually have two options here. Now you can see a couple of the runtime that are available. That's .NET, Go, Java, Node.js, Python. And what we are looking for is actually the one that says provided. We have AL2, this is what we're looking for. And we have a handler. This is actually not important in this context because we are using a custom runtime, but we can just give it any name we want to. Test func. And the next thing we can now, of course, importantly, is our code. You have a couple of options. You can put it in S3 bucket and then pull your code from there when it's deployed. You can actually, of course, bundle everything together during deployment as zip file. In this case, I would just want to copy the binary basically from our local build and then have this deployed. So our code would be lambda code from assets, S from assets, and JSII string. One more to close that. It takes a second argument. Options, but we can just pass now. And now I would just like to point it to our binary. So if we look here in the source folder, if we look into targets, we'll see lambda, and then we'll see the folder that contains our binary we have just like called bootstrap. Right, so that's basically what I would like to point. I want to point to this location basically in here as our assets, so it can get picked up during code upload. So we go out one level, go into targets, and then go into lambda, and then of course go into reverse to lambda. Yeah, that's correct. And one more thing I would like to set is current version options. Lambda version options. So this is basically to help me set things like my retry attempts, removal policy, what should happen, for example, when I destroy the stack, whatever, what should happen to resources. In this case, I want it completely destroyed. So removal policy, AWS CDK. It's removal policy dot destroy. That's what I want. And try attempts. We're not really doing too much. I'll just say once. I just want a number. Why are you giving this? That's fine. So we've defined our function. Basically, that's like most of what we need actually. The next thing I want to actually do is to define an API gateway. Let me find the URL. Should be this. I don't know if I have it installed. API gateway. And the next thing I want to do is to put our function behind this API gateway. So AWS API gateway, new, lambda REST API. Let's see if that is even how to go. I'll do one more time. For each stack, also when you write your own stack, they have to have a certain signature, as you can already see from line 22. It takes a scope, ID, and props. So if I hover over new functions, which of course would instantiate it should be a stack for creating a lambda function. See, it has a stack, an ID, and props. If I also come to REST API, see, it has a scope, ID, and props. That's mostly the signature they all do the thing to us. So also here we pass a stack as ID, and we give it a scope, and we give it an ID. I'll say my API. I don't know. Because again, it has to be a string, and then props that are specific to this service. API gateway props. And one important thing I want to define here is the handler. I just pass the function. And that's mostly it. Maybe the last thing I would want to do is to just have some outputs, I guess, in the CDK. Outputs. Again, the same scope, ID. Give it, let's just, I don't know, what should I call it? Service account. Let's just say, what do I even want to print out? So the API URL. I don't know. I could say API URL. Because the ID, you can give it whatever you want to have. Again, scope ID props. AWS CDK, CFN output props. What do I want to output? The value would be API. Now I have a couple of things. ARN, blah blah blah. The only thing I think I'm interested now is the URL. And I return the stack, and that's actually it. We are done, guys. So we define a function, a lambda function, we give it some props, we define the runtime. Actually, of course, if you hover over this, you have all the possible things you can actually define for this props. You get to decide, depending on what you're working on, you have the option of setting all these other attributes. But for now, of course, see here, you can attach layers if you want, retention for the lambda function, and so much and so forth. Like memory size, you also get to define that. So this could also be scenarios whereby like you're working in an organization whereby you work with a lot of lambdas, and you could decide to define, like, say for example, every lambda you want every lambda to have to run on, say, I don't know, in Node.js runtime, for example. You could have a stack, and then here you have this defined so that whoever is inheriting the stack will always create lambdas that have this runtime. So that's just one thing. Of course, you can, it's not only It's not only for CDK. Of course, you can do this with any other ISC tool, be it Terraform, blah blah blah, whatever. But that's just the point. So that's our function, and we created, put our lambda behind this REST API. So now what we want to do, of course, we have our CDK installed. We can cross check one more time. It's installed. So the first thing we need to do is we synthesize a CDK template. Basically, it looks at the code we've written and generates a CloudFormation template. So we say CDK synth. Ignore the warning, just tell them it's not about my version of Node.js. It doesn't really matter so much. It will not break anyways. So we are synthesizing a CDK, a CloudFormation template, because like I said, the provisioning of services is actually done. So this, the way it works is that CDK synthesizes a CloudFormation template, and at deploy time it uploads this template to CloudFormation. So the CloudFormation does the provisioning based off of the content of the CDK template, of this template that is being generated right now when we just run the code CDK synth. And we can also take a look. I think the video is becoming really long. I don't want to be much longer than needed. This is what it looks like. You can already see. If you read through it, you see all the things we're creating, and we should be able to find it, if I can remember, IAC stack template, and this is what it looks like. But anyways, let's just proceed. And another thing I've done also is I created a profile, a user profile on AWS IAM, and gave it all required permissions, and the profile is called YouTube. So basically I can now say CDK deploy, and I pass my profile. I called it YouTube, and now I'm asking it to deploy. So it will take everything we've created and then synthesize the template, and then upload the template to CloudFormation, and then CloudFormation will take the template and do the provisioning for us. And what I can also do is to go to my AWS console and then go to CloudFormation and also show you, so you see what's happening along with me. So once the provisioning starts, we can come here and see our stack appear here. Okay, now we see some of the changes that's been proposed to be made. And when we are through, we've gone through what would be created and everything, and we are okay with them, we can just accept by typing in here yes. And now the deployment should start, and now we can actually go to the browser to see what's happening. So if we come over here, if I refresh, you would see there is IAC stack, which was what we had locally, and we can actually go into it and see what's happening in here. We can look into the events to see what's started, what's finished, and all that in progress and everything. And then we can also just go to resources to see the actual AWS resources that have been created. And if we go back to here, we would actually see that's everything we see in the browser on the AWS console is what is being again shown us back here. And now it's actually done. And so if you look here, it says IAC API URL, and it shows us the API URL. It's able to show us this actually because in the outputs, I requested one output here and I named it API URL, and that's exactly what you see out here. So this could also be a way to get outputs out of your deployments and maybe use them for other things, consume them whichever way you want. So if everything works well, it means we should be able to take this URL, go to our HTTP file, replace all our, like here for example, we should be able to replace this part and invoke our lambda, and it should still work. So it looks like it worked. This was what we got initially. We are getting our users, and if we probably have to collapse this part. If we, for example, like we did, say we wanted to add some ID to just get one, say ID, and we say, I don't know, whatever, and we should just return one. It's looking nice, like it should. And of course, we can do the same for our posts. Simply just change this part from localhost to the URL we got back and send the post request, and this works. And we do same for our deletes, and it should still work. And one last thing I would have to do, of course, is I would not like to rake in charges in the end. So the last thing I would need to do would be to really destroy the resources that I created on AWS Cloud. So if we come back here one more time, we can see what was actually created. So if I refresh just to be sure, there is a function, an API, and of course this is CDK meta. So what we need to do now is basically destroy everything we've created, and we get to do that, of course, with CDK with just one command. So this yes, so all we need to do is CDK destroy, and I'm going to use the same profile that I created, and it's called YouTube. And then everything that was created would be destroyed. And if we, of course, look at the browser, at the console, we can actually follow the process go on. So guys, that was it. Thank you so much for taking this journey with me. I hope this was really helpful to someone. And please feel free to leave your comments or notify me or kind of like chat me, however you want to do it. Reach out. If you have questions, or if you have things you think you would want us to discuss, I'm always open for that. And yeah, thank you once again. Thank you so much for being part of this journey, and please subscribe so that I can always be encouraged to bring you juicy topics that you would always find useful. Thank you so much, and have a wonderful evening. Bye.